The pile driver system is shown in the figure 1. The steel arm of mass 2000 kilograms is pivoted at point A is shown in figure 2 with its dimensions. The center of gravity of the arm is located at G. The pulley of mass 200 kilograms is attached at the upper end and B of the arm, and it can be rotated by an electric motor. A cable is wound around the pulley and its free end is connected to a steel cylinder of mass 800 kilograms. Neglect the mass of the cable. The length AB and AC 10 centimeters, 10 meters and 2 meters respectively. The horizontal distance from point A to the line of action of weight of the steel arm is 2 meters. The arm is operated using a hydraulic system. Part A. To keep the arm and its attachment at equilibrium position, the F1 force has to be applied at point C using the hydraulic system as shown in the figure. The direction of F1 is perpendicular to the length of AC. Calculate the value of force F1 by taking moment about point A. For this calculation, neglect the size of the pulley. Now we have to calculate the force given by point C. They have given, we have to consider torque around point A. Then I will write torque around point A. Counterclockwise torque should be equal to clockwise torque because to system equilibrium. To keep the arm and its attachment at equilibrium position. Therefore, clockwise torque should be equal to counterclockwise torque. Now there are 4 forces. Mass of pulley 200 kilograms, mass of cylinder 800 kilograms, mass of arm 200 kilograms. There are 3 weights due to masses. And there is only one force given by F. Now there are 4 forces. But we can consider the action line of these 2 forces, 200 and 800, is the same action line. Therefore, we can get force along this action line 200 kilograms plus 800 kilograms, 1000 kilograms. 1000 kilograms. We have to use force, then 10,000 newtons. And due to the mass of arm 2000 kilograms, there is a force 20,000 newtons. Now there are 3 forces, 10,000, 20,000 and F1. We can consider torque around point A. When considering torque, there are 2 clockwise torques due to this force and this force. And there is only one counterclockwise torque. Then we can get counterclockwise torque F1 into perpendicular distance from A is 2 should be equal to clockwise torque, sum of clockwise torque 20,000 into perpendicular distance from A 2 meters, it is given in the question, plus 10,000 multiplied by, now we have to get perpendicular distance, this distance. When getting this distance, we have to use this 10 meter length. And we can write, we know that in the given diagram, this angle is 90. Therefore, this angle is 30. We can consider alternate angles This angle also 30. Then we can consider this triangle. We have to find opposite. Hypotenuse is 10 meters. Sin 30 equals opposite divided by 10. Then we can subject opposite 10 sin 30. 10 sin 30. It is the perpendicular distance. Now we have to simplify. We can cancel out all three terms by 2. Divide by 2 1. Divide by 2 5. Then F1 equals 20,000 plus 10,000 multiplied by 5. We know that sin 30 is half. Divide by 2 1. 5,000. 20,000 plus 5 into 5 25,000. 45,000 Newton. It is the F1 force required to equilibrium of the given system. Then part B, the force F1 in A above is provided by compressed oil of hydraulic pump as shown in the figure 3. The cross-sectional area of the piston of the master pump is 4 square centimeters. Cross-sectional area of piston at C 60 square centimeters. The force F2 has to be applied for the piston of the master pump in order to obtain the force F1. Part 1, name the principle that must be used to calculate F2 force. We have to use Pascal principle. Pascal's principle. Part 2, find the value of F2. When using Pascal principle, the pressure at same height in a same liquid is constant. Then we can write, I will draw a rough sketch. Master pump is like this, and there is a tube between two pumps. They have given the diagram, but I will draw to explain. When considering this point and this point, we have to get 2 points at the same level. Then F2 force is given to the master pump. F1 force is obtained by this pump. I will consider this point as X and this point as Y. Then pressure of X should be equal to pressure of Y. There is the same liquid between two pumps and there is the same horizontal level for two pumps. Px equals Py. Now we know that pressure equals force divided by area. Then we can substitute pressure at X, force F2 divided by area of master pump equals to pressure of Y, F1 divided by area of this pump. Then we can substitute. We have to find F2 value. Area of master pump is given as 4 square centimeters. I will use square centimeters because of we are using square centimeters for both sides. We can cancel out it. We can't. Therefore, it is not compulsory. The unit conversion to square centimeters to square meters. F2 over 4 equals F1 divided by F1 force is found as 45,000 divided by area of this pump is given as 60 square centimeters. Now we can simplify. Divide by 6 1, divide by 6 7 42, 3 remaining, 30 divided by 6 5 0. We can multiply 750 and 4. 0, 4 into 5 20, 2 remaining, 4 into 7 28 plus 2, 30. 3000 newtons. In part 3, what is the pressure of the compressed oil in hydraulic pump? We can use this part or this part of the equation when getting pressure. We can write pressure of compressed oil. Part 3. Pressure equals force divided by area. Now I will use F2 divided by capital A area. It means area of master pump. F2 value is 3000 divided by area of master pump 4. But we have to convert 4 square centimeters to square meters because of we have to find pressure in SI unit, Pascal, or Newton per square meter. Then we can substitute 4 into 10 to the power minus 4. We know that when converting centimeters to meters, we have to put 10 to the power minus 2. But in this equation, we have to substitute area. We have to convert square centimeters to square meters. Therefore, we have to put 10 to the power minus 4. Then we can simplify it. 3000 multiplied by 10 to the power 4 divided by 4. 3000 divided by 4, 750 into 10 to the power 4. Pascal or Newton per square meter. Part 3. The radius of the pulley is 10 centimeters. The moment of inertia, I of a pulley of mass simple m and radius r about its axis of rotation can be given by I equals half mr squared. The cable moves without slipping. Part 1. When the arm is at its maximum vertical position, as shown in figure 2, the steel cylinder is moved upward at a constant linear acceleration of 0.5 meters per second. By rotating the pulley, calculate the torque that must be applied to the pulley by the motor in order to raise the cylinder. Now I will draw the pulley and cylinder. We know that weight of cylinder is 8000 newtons. 800 kilograms, we have to use force 8000 newtons. And it is moving in upward direction with a 0.5 linear constant acceleration, ms minus 2. And we can find the moment of inertia of the pulley. They have given the equation moment of inertia half mr squared. Half mass of pulley 200 kilograms, radius 10 centimeters, we have to convert it to meters, 0.1 meters squared. We can simplify it. 100 into 0.01, 1 kilogram square meter. Then we can find the tension of this cord. When finding the tension, we can use F equals ma to the cylinder in upward direction. Now upward force is tension. We have to subtract downward force 8000. We have to substitute resultant force as F. Mass is 800. Acceleration 0.5. 800 into 0.5, 400 plus 8000. Tension is 8400 Newton. Then we can apply tau equals I alpha to the pulley. we can use tau equals I alpha in counterclockwise because of pulley is rotating in counterclockwise direction. Now we have to given a torque tau to rotate pulley to counterclockwise direction by using the electrical motor. We have to find this tau value, and there is an opposite torque due to this tension. Then we have to subtract torque due to tension is tension multiplied by radius, force into perpendicular distance. Force into perpendicular distance, it is the opposite torque. This is the torque given by the motor to rotate pulley, and TR is the opposite torque. It means the torque we should give to rise this object with an acceleration equals to I value is 1, it is found in this part, alpha. When substituting alpha, we know that alpha is angular acceleration, and there is a relationship between linear and angular acceleration. If the linear acceleration of this object is A, it is the tangential acceleration of the pulley, and the relationship between tangential acceleration and linear and angular acceleration is A equals R alpha. Then we can substitute tangential acceleration 0.5. Tangential acceleration of pulley equals to linear acceleration of this cylinder equals to radius 0.5 into alpha, 0.1 into alpha. Then 5 radians per square second is the alpha value. We can substitute it to this place. Then we can find the tau value. Tau minus tension is found as 8400 multiplied by radius of the pulley is 0.1 meters equals to 5. Then we can simplify it. Tau equals 8400 into 0.1. We can cancel out 1 0 with 0.1, 840. We have to bring in to right hand side. 840 plus 5. Torque is 845 Newton meter. Part 2. When the cylinder has moved upwards to a certain height, the motor is switched off and the cylinder comes to momentarily stop after some time. Next, the cylinder attached to the cable is allowed to drop into the pile while the pulley rotates freely. The center of gravity of the cylinder drops from a height of 45 over 8 meters before the cylinder hits the pile. Calculate the velocity of cylinder just before hitting the pile. For this calculation, neglect the frictional torque acting against the rotation. We can use the conservation of mechanical energy when falling the object. Now, the pulley is rotating freely and becomes to rest before the free fall, and therefore we can consider for the initial situation there is no rotational kinetic energy for the pulley, and there is no kinetic energy for the cylinder, but there is a potential energy. We can get potential energy of cylinder as mgh. When falling the cylinder, pulley is rotating. Therefore, there is an increasement of rotational kinetic energy of the pulley, and the velocity of the cylinder also increases. Therefore, there is an increasement of linear kinetic energy of cylinder. We can write kinetic energy increasement, linear kinetic energy increasement, half mv squared. Initial linear kinetic energy is 0 at this stage. Plus rotational kinetic energy before colliding the cylinder to the pipe on the pipe, half I omega squared. This is the linear kinetic energy of cylinder, and this is the rotational kinetic energy of the pulley. Sum of these two energies should be equal to mgh. Then we can substitute values. Half mass of the cylinder is 800 kilograms. Velocity, we have to find the velocity before colliding the pipe. It means final velocity of the linear motion. We have to find it. Half I value is 1, it is found, and we know that angular velocity v equals r omega, then we can subject omega v divided by r. Then we have to substitute square of this term, v square divided by r square, equals mgh. Mgh means potential energy decreasement. There is a decreasement of potential energy only for cylinder. Then we have to substitute mass 800 kilograms, G10, height is given as 45 divided by 8. Now we can substitute radius 0.1 meters, radius of pulley, and we can simplify, we can get the value of V. Divide by 2, 1, 400, 400 V squared plus V squared divided by 2 times radius 0.1 meters, square 0.01. 45 into 10 to the power 3, 45,000. We can bring 0.01 to the numerator as 100. Then 400 V squared plus V squared divided by 2 into 100 equals 45,000. Divide by 250, 450 V squared equals 45,000, and we can cancel out by 450. V value is square root of 100, 10 meters per second. It is the velocity before colliding the cylinder with the pipe. Pile is given in the diagram figure 1. You can identify the motion by using figure 1. Steel cylinder is moving downward and colliding with the pipe. Then part 3. This is the answer for C part 2. Part 3. After collision, the cylinder and pipe penetrate as a composite object into the soil without any recoil. What type of collision is this? How do you identify this type of collision in terms of loss of kinetic energy? Both objects are moving as a one composite object. It is a perfectly inelastic collision. Perfectly inelastic collision. because of objects are combined. We can identify the collision type by using kinetic energy. There is a maximum kinetic energy loss. If the kinetic energy loss is 0, it is an elastic collision. But for an elastic collision, objects are moving separately after the collision. But in this collision, objects are moving as a compound object. Therefore, it is an inelastic collision. It means there is a maximum kinetic energy loss. Then part 4, calculate the velocity of the cylinder and pile just after collision. The mass of the pile is 480 kilograms. For the collision, we can use conservation of linear momentum. In part 4, they have not given about the tension of the cord, but we know that when colliding objects, the cord will shrink and tension of it is 0. Therefore, it is not depending the motion, not depending the collision. Then we can use conservation of linear momentum. In the downward direction. Momentum before the collision, mass of cylinder is 800, velocity 10. This is the momentum of cylinder before the collision. Before the collision, the pile is at rest, therefore it has no momentum. After the collision, both objects are moving as a compound object, as a one object. Therefore, we have to consider the sum of masses. Mass of the pile is given as 480. We have to add to 800, then 1280. 1280 is the total mass. We have to find the final velocity. I will consider it as V dash. We can simplify it. 800 divided by 128. Divide by 4, 32. Divide by 4, 200. Again divide by 4, 8. Divide by 4, 50. 50 divided by 4, 8. 50 divided by 8, 6. 48. 2 remaining. 20 divided by 8, 2. 4 remaining. 60 divided by 40 divided by 8, 5 meters per second. Then part 5. If the distance penetrated by the pipe is in one hit is 200 centimeters, calculate the average value of resistance force produced by the soil against penetration. Take 6.25 squared as 39. Kinetic energy of the system. System means pile and cylinder. Should be converted to energy or work done against the friction. Then we can use again conservation of kinetic energy. Kinetic energy of system half mv squared, half m 1280, v squared we have to substitute square of this value, 6.25 squared. It is the velocity after the collision. Should be equals to work done against friction is frictional force into distance. Then half 1280. They have given square of system is 39. We have to find the frictional force. Distance traveled to the soil is 20 centimeters. It means 0.2 meters. We can cancel out 2 divided by 2, 1, 640. And we can get 640 into 39 divided by 0.2. I will give it, get it as 2 divided by 10. 2 divided by 2, 1, 32, 0. Then we can simplify it. F equals, there are 2 zeros, we can put it at the end of the answer. 32 into 39. 9 into 2, 18. 1 remaining. 9 into 3, 27 plus 1, 28. 3 into 2, 6. 3 into 3, 9. 8. 8 plus 6, 14. 1 remaining. 2 plus 1, 3 plus 9, 12. Newton.